Hello, physics. So we're getting ready to do Hooke's law. So you're going to use this simulation, a Colorado simulation, really, really good. Here's what you're going to do. So you're going to open it. It should look like this when you come into it. So you're just going to click the intro. The first thing you're going to do is the equilibrium position. And so the equilibrium position is the point at which the spring is relaxed. In other words, notice how this gripper thing isn't there. It's like I have a regular old spring and it's just ready and relaxed. If I let go of it, it's not going to do anything. It's just going to sit there and relax. This is what's called the equilibrium position. So what we're going to talk about is putting some kind of elastic energy into that spring. And the best way I can do that is to either push in on the spring or pull it out. So what I can do is I can click here and I can pull it out. And notice that in order for me to do that, I have to apply a force. And in this case, I applied 53 newtons of force if I'm going to hold it right at that position. So in particular, in this lab, what we want to focus on, is I'm going to apply this amount of force. How much did it actually displace? And so I'm going to click here, and if I click on the displacement, it's going to show, well, from the equilibrium position, which is at rest, the spring displacement would be however long this arrow is. And I can get the value for this by just clicking value. And there it is. It's 0.264. So notice that if I want to pull it farther, like I've displaced at 0.5 meters, that's the spring displacement. But I have to apply 100 newtons to do that. And so then I can also go this way with it as well. I can crunch it down. And now it has a tendency to want to return back to its original position. So I've applied a force, but in order for me to displace at 0.5 meters to the left, then I had to apply this many newtons of force. One thing that's really important is this. When you do this lab, any displacement arrow pointing to the left, like this one, should be called negative. Any displacement value pointing to the right should be positive. Okay, so here's your assignment. You will pick a spring constant that varies. So let me set this to 0. You will pick a spring constant of whatever you want. Do not just pick 200 because that's what it'll default set to. So you can increase the spring constant, and notice what happens to the spring when I increase my spring constant. It gets a lot thicker and more dense. And I can decrease it, and then it also becomes a lot thinner. So you're going to pick one. I don't care what it is, but you're going to pick one and make sure that you specify what it is. Then you're going to pick 5 different forces that you're going to have, and you will measure the displacement. So if I had 1,000, then I could go, here's 1 data point, here's 2 data points, here's 3 data points, here's 4 data points, here's 5 data points. Got it. And then that's my data. And so that's it. Then you will just follow the instructions on the rest of the paper. Cool.